So, welcome back to the Developers Day. I'm Stephen Robinson. I'm a digital developer for project operations in the Digital Innovation and Research Service team at Lancaster University. Please feel to tweet, take pictures. I know it's been videoed. And you've probably seen me on Twitter throughout the conference because I've been tweeting a hell of a lot. So, a bit of a brief overview of this session. I'm going to go a bit about what I mean by intelligent user services, a bit of background on some of our current provision of some services we developed with the Alma APIs, getting ourselves ready to deliver these intelligent user services, and then hopefully, if the Wi-Fi behaves, we'll go have a demo with the Amazon Echo. So before I get into that intelligent user services, though, our team, we have a vision. It's summed up as three things. Great service that leaves you with a smile, at least not a frown. Great user experience wherever you are worldwide. And by doing that with great staff. And yes, it seems a bit coveted, a bit markety, but it's really useful in us designing services. It gives us three key things to make sure we're hitting with whatever we deliver. So intelligent user services, I think we can do a lot of things with technology. And it's really good, but unless we're delivering services to our users at the right time with the right information, there's too much information out there and we're not doing our best efforts for them. So I sort of summarize intelligent user services around three concepts. One is personalization. So that's personalizing the service to the person about very specific attributes to them. So if we're talking students, it's what course they're studying, what year in that course are they. Are they doing certain modules? So at that time, we might push stuff that's on their reading list out to them. And then similar to that is contextualization. So and for me, that means, are they in the library? Are they out the library? Are they at home? Are they a distance learner? And that's the more broad categories of user. So it might not be who you are specifically, but a broad category you fit in. And finally, innovation. So that's, as I used to use the word, exploiting technology. So making the best use of it to provide what we do and try and be on the leading edge of that. So not just doing something because someone else has done it, trying to figure out the best ways of doing that ourselves. And there's a great Gartner this year said that conversational first will be the most important high-level design imperative through to 2023. I hope most of you know who Gartner are and have read some of their stuff. But that's really important when you think that humans can talk at 140 words per minute, but can only type at 40. So I think we can speak a lot faster, so why aren't we using that as the way they engage with our digital services instead of typing? And one of the things Amazon have done with that is the Amazon Echo. So it's their series of intelligent home assistants, but they now have also brought out Alexa for Business, which is their business platform that lets you use these devices in an education or enterprise concept. And if we go look in the US, St. Louis University in Missouri in the US have just done a partnership where they've released an Alexa skill, and they're putting over 2,000 of these into their resident halls and student rooms on campus. So I'll leave that quote there, but some of the things they've been doing is it's a very informative skill, but not a very intelligent skill. So you can ask the library when it opens, when it closes, but you can't ask the library what items are on your account. Can it renew something for you? And I think for us, that's an intelligent service, is one that can answer those questions, not just tell you a fact and figure that you can Google. So if we look at our current services, a lot of this is around what Josh and other people have mentioned earlier today about using the APIs to highlight your library account information. So we do that in our student and staff portal. Hopefully that's readable. So we show what they've got on loans, any fines outstanding, and that's actually based on, we were early adopters of Alma back in 2012, around 2012, 2013 in the UK, and the APIs don't exist to the level they do now. There was no REST API. It was purely a SOAP API. So we had to do a lot of custom development to show what items are on loan and when they're due back, any fines that the user has outstanding, but also our students ask us a lot, can we show the requests, how long that request is going to be there, when is it going to be ready for them? And we currently don't do this or display it. And if we look at the mobile offering, is done through what we call iLancaster, which is a Campus M mobile app. If you've been to any things, you'll see something that looks very similar to these screens. The one I'm quite highlight is, if you look over there, that's the fine ID, the actual ID number within Alma for the fine. But for some reason, that's the title we're giving it in our mobile app, which I was surprised at because I never used the app. When I opened it up and saw that, I was, from user experience point of view, that is terrible and something we maybe need to really look at when I go back. So that's only recently also moved over to using the native integration with Campus M for Alma. Before that, we used our current API in very inverted commas. It's XML-based. It looks a bit like that. So return the IDs of the user. I've just hidden mine out, who they are, whether they're staff, student, any fines they have, and some details on that. So I've removed all the other ones to keep it brief. And we've also got down here the loan items, and we'll see how that fills in later. So how is this built? Well, it's a single endpoint, which is great for our corporate team in our IT department to develop against. They have one endpoint they can call. It returns all the relevant library information. They don't have to deal with any changes to Ex Libris's APIs. But it's not flexible. So it won't let us deliver any of these intelligent services. It has, it basically acts as a pass-through proxy. So the request hits that, and it makes a load of API calls to Alma, doesn't cache them, doesn't do anything, and just returns the data back. And it's outdated. We wrote it on the SOAP APIs using Java. We don't develop in Java anymore. So there's a lot of technology stack around it that we don't want to use anymore. And that led us to what I call our library API gateway. So at Lancaster, we don't just support the Ex Libris suite of the development team in the library. We support over 40 different, in most cases, in-house developed services. Many of these are all API-driven, so we're trying to get a way of bringing all that data together in an easy place for anyone else across the institution to integrate. So why did we want to build one, and why didn't we just use the Alma APIs that natively exist? So traffic management. If any of you know, there's an API limit in terms of requests per second, but also the max number of requests you can make a day. When developing this, we were constantly hitting that limit for about 6 days in a row. And when you have a load of other integrations that use it, it's a bit of a shame when your user loader goes down and other systems like that stop working. So it helps with that, but also caching, caches the data. This has been done in a lot of different places around our institution to cache library data for the different systems, so be that our student portal, our staff portal. They're all caching the data, and we'll find users are constantly coming to the library saying, I've returned this, or I've paid this fine. Why is it still showing on my account? So we want to centralize that caching to one place where we can be in quite a lot of control over that. End user authentication. So I'm going to touch on another point later on, but the Alma APIs are great as systems developers, where we want to be a developer integrating on the server side. If we want to integrate into like Alexa, we need to have authentication on the API that lets us know who the user is. So OAuth, JWT, JSON Web Token, anything like that. And it's also to support those internal stakeholders. So if we can tie it into, we use JWT a lot on our internally developed systems across the institution. If we can have our API, one of the authentication options be that, it means they can just send requests from their browser to us. They don't have to do any server-side coding themselves. And as I said, that service development over systems development, and that big, it mainly coming down to authentication. And then finally, we want that single interface again, where we give one endpoint that returns all the user data. That is possible in Alma, but there's certain fields that don't get returned. So the flag is an item renewable. That's actually computed on every API request you make, because it's based on your rules set in Alma, who the user is, and the current date time. So you have to call each item individually to be able to check that. So from that, we came with some requirements. Key for one. So one of them is scalable. We have to be able to scale to our peak traffic. We only have 15,000 students, but we also have a lot of partner campuses across the UK, and we wanted to build something that was also relevant for anyone who wanted to use it. Modern, so we want to use a modern architecture, modern technology stack. Adaptable, so we can easily change how it integrates with Alma, or if we went to any other product or any other system we build, but also support those innovative developments we want to do. and then maintainable, so making better use of being able to easily and quickly develop in a very agile way on that. So in building one, we decided to look at what technology was out there. We started using Amazon's AWS services in the library a lot, and our institution's now looking at them as well. So we decided to look at what's out there, and if you into the technology, if you see a lot on Twitter, there's a lot of stuff about using serverless functions as service. That's the Lambda stuff that's been thrown about a bit as well. So we use the serverless framework. It gives us a nice vendor-agnostic, platform-agnostic tooling to develop stuff. So all we have to change is that small bit of code that is unique for Amazon or unique for Google or unique for Microsoft. And sort of to manage that, we're using a bit of infrastructure as a code. So Terraform is really good. It's, again, vendor-agnostic, which is great because we're also trying to use this to manage our locally hosted infrastructure as well. And then Node.js is a great programming language. It's heavily supported on every Lambda platform, function as a service platform out there. So if we have a look at how we've been developing this, so I don't know what practice anyone uses, so I thought I'd go over a bit of how we decided to modernize a bit to that. So we're using a bit of a continuous delivery workflow, and I will highlight continuous delivery is completely different to continuous deployment, and it all comes down to that last bit. It's that little padlock there is where the difference lies, and I'll get to that in a minute. So we start with the developer here. We use the GitHub flow style, so they create a branch, do a load of commits, and then they open a pull request. We send it off to Circle CI to do some tests. We use Code Climate for code quality and also identifying any CVEs or other methods. We do peer review, so we'll do a code review on that, have a look over it. And it's not about language. So it's not a language expertise person, it's a domain person. One of the other developers looking over the code, does the choices make sense in terms of what we're calling things, how it might be interacting with a certain other service. And if that all passes, then we merge it into master, which triggers the test suite to run again, and deploy straight out to our staging environment. And we're doing that. Recently, we've been doing that 10 times a day, pushing out small features into our staging environment. And ideally, that can be manually approved and deployed into production. And because we're using serverless, we have that, which uses Amazon's CloudFormation language underneath. We can roll back if anything goes. So if the deployment's fails halfway through, our production environment is still running the live code. It's still like the working code is still getting requests, whilst the deploying code isn't. So if we have a look at moving on to, we've got that workflow in place, so how are we actually getting the data and building it? So there's a few different ways we can do it. We can do polling, so we can, on a regular interval, query the Alma APIs. That's good, but that doesn't solve our problem of hitting the API limit. If anything, we'll hit it more often. Then you've got nightly sync. Seems reasonable. We'll sync the data once a day. It doesn't use many API calls. However, we get stale data, which is another thing we're trying to avoid. We can use proxy caching, so just adapt what we've built already to cache the data locally. Or event-driven, where we want Alma to tell us what it's doing, which you can do with Alma. You can use webhooks. So Alma, 2 years ago, there was only a job end, and now we've got a wide variety of different endpoints that I'll get onto in a minute. But if you don't know what webhooks are, a technical thing, they're user-defined callbacks made with HTTP. At the friendlier level, they're a way of apps sending automated messages, information to other apps when things happen. So Alma supports 7 different types. So they're job end, notification, bib, item. So I'm not going to go into too much details on them because they're not relevant for what we've developed, but they are there and you can get information. The ones we're quite interested in are user. When user information is updated, which is really good, but there's a slight problem in that if you update your user records by API, there are no webhook events sent when they're updated by API, only when they're updated in the interface. So for us, we're trying to figure out why that was a decision that was made. Then you've got loans. So whenever any loan-related events occur, so that's created, renewed, due date changed, relate to that, and then a request created. So we're really interested in these bottom 3 around here, and that's what we're integrating with and using to power our system. And if you want to know a bit more about webhooks. I'm not going to cover how to set them up because Josh has done a talk at the Developers Day 2 years ago on how to set them up, and there's a video on YouTube of that, which I'll try and put on Twitter later. So if we have a look at what we've built, so let's start with the webhook handling side. So how do we handle the webhooks? So it looks a bit like this. We have Alma over here. And then we're using Amazon's API gateway to provide an interaction, a HTTP endpoint that can be called and pass it off to a Lambda function in Amazon that will scale. So all we're doing is turning on everything and sending it to this one Lambda. And that's then sending it out to different SNS topics. So it's like a publish-subscribe message system. So we create one for each of the areas we're interested in. And this is actually the key point for building the intelligence services, because we can send that out to our users and say, if you're on our Amazon platform, if you want to do something when a loan is returned, you want to track that, just subscribe to our topic and we'll tell you that event and you can process it and do what you want with it. And without having to deal with what Alma is, know how that works, they just get the event. And at the minute, we're just sending the raw data through that comes on the webhook, but we could write some logic here to change what's sent through. And it's that step, the key thing is the expendable bit. We just have to add another topic and change a case statement to rely on the event type that's sent through on the Alma webhook. And that's the heart of our intelligent thing on webhooks. But then we're wanting to cache the data, as I said. So caching it looks a bit more complicated. So we have our topics again on this side, and they talk into 4 different lambdas. So we've got loan updated, loan returned, request updated, and request closed. And they're all writing data to DynamoDB, which is a NoSQL database. You pay for write-through capacity and storage, not a server of X size. So for us, it's great if we know there's going to be a peak period where, so we know at the end of our 3rd term when all our students are returning items, we're going to get hit with webhooks, events of everything returned. We can just automatically scale up that database to handle that traffic and then scale it back down, so we're saving on cost. And I'll mention later how much it actually costs us to run this in Amazon. And then we've got this user update queue here. So, there we go. And that's basically if we want to update user information or if when a webhook comes in, if we're saying, oh, that's a loan on my account, but if the cache doesn't know about my account, what's the point of caching one loan? I should, at that point, update my whole record and make sure I'm caching everything that we want. So that queues up my ID to be refreshed. And that queue basically lets us give away, if we know we're hitting a limit, an API limit, we can back off the queue and say process event at a slower rate. And by doing it at a slower rate, we're making less API calls per second. We're making less per day. Yeah, and obviously it's all Lambda, it's all serverless. There's no servers for me to manage. It's great handles. So following that, we've got the bulk update. So this is the bit that's doing a bit of a fan-out design. So basically, the user update comes in here, and we call the user's endpoint on Alma. And we get their data from the API. And then with all their loan IDs, fee IDs, and request IDs, we put them onto each of different queues here. And once they're queued up, they're going into different lambdas, which are querying the APIs up here to get the fields and the details we want that aren't available at any other point, and all storing that in DynamoDB. And that key thing is that queued update to get around that API endpoint. So if we put that all together, we get something that looks a bit like this, and hopefully it's not chopped off good. So it's quite a serverless, scalable approach. We can easily add bits in here without having to go over here and update it. But most of it, the key parts for being able to create new services are all in this side, and that this is just a cache of data that we're using for different things. And I've mentioned the word cache, so I've got to mention cache busting. And caching is terrible, and cache invalidation is even harder. So there's 3 different ways we're dealing with this. So the first one is user record expiry. We made a guess at 2 hours. That will cache a user's summary record, which is the IDs of their loans, the IDs of their requests, and the IDs of their fees for 2 hours locally. because we know that normally they're going to be hitting our student portal at one point in time and then probably not coming back to it for a few hours or a day later when things might have changed. But that's configurable, and we're hoping over this next year to actually get a better understanding of, is that timeout correct? Are we hitting the cache correctly? And then we've got record TTLs. So DynamoDB has a great feature. You can set a timeout on a record, and it will automatically purge that data out for you. So you don't have to worry about deleting that data from the cache and worrying about when you get rid of it. If you set the time to live field on it, it'll do that automatically. So we made some decisions that students probably don't return everything on time. We don't fine them if they return it late, only if it's recalled. So adding 2 weeks to it is a sensible default value, and especially if we're listening to the webhooks, when they return it, we'll cache bust at that point. Requests are at 2 weeks and fees are at 2 weeks, and they're just an educated guess. We're not sure whether they're correct, so we're going to be doing some monitoring to figure out if that's correct. And then webhooks have also been used to invalidate the cache, so if the due date changes, it'll update the record, change the TTL. If they're returned, it'll remove them, and then closed or cancelled requests are removed from the cache as well, because we're not deciding not to show that data back to users. So I mentioned monitoring the cache. So we use Datadog as our monitoring and metrics platform, and now our logging platform. It's really good. It's software as a service. It has a really nice integration for Amazon, which was our key point in choosing it, because the CloudWatch metrics and dashboards you can create in Amazon are really good, but they're really difficult to understand what is the difference between average, sum, count. Sum and count are very different in their concept over a time period. So we're looking at the hit and miss ratio. So are we configured these TTLs correctly? Are we hitting Alma at the right times? Webhook events, so how many are we getting? How many events are going into each topic? How long is that webhook process, that webhook lambda running? And have we got it pre-warmed? So there's a concept in serverless programming that the instances behind it are spun up in time for you needing it, but that means you get a slow start. So the first couple of times you hit it, it'll be really slow, and after that, it'll be really quick. And it's make sure we're handling that correctly. Then we've got queue length. So as we're queuing up then bulk updates and then loan record updates, it's making sure that we keep an eye on how long them queues are, and have we got enough workers processing them, and also knowing that if we turn them down to tweak for Alma API limits, are we still going to be there to work? Are the queues not backing up too much? And then finally, some metrics on Lambda execution, so time to run, success error rate, and concurrent execution, so how many we're running in parallel. If we're starting to run 20 or 30 events in parallel, is there something we're missing, a trick we're missing in our coding to do something cleverer about that? And then with that, we publish an API. So the cache platform that I've just described there is separate from the API platform. They do use that cache database. They interact through that database of data, but we see them as separate services. And the cache is at the heart of all of these services we're trying to provide, because it gives us an easy way to constantly query our own data without making API calls out to Alma and hit limits. So I'll go pull up them points again. So traffic management. Amazon can scale. We don't have any issues with scaling at Amazon. We ran a test on it, and I said, send me a million web events over an hour, and it was handling it. I then dropped it. In time, it was still handling it. You'd see a bit longer time if we didn't change the database concurrent requests to the database. So we didn't increase that limit, we would get issues. But with Amazon, you can say auto scale, so it'll do that technology of fancily figuring out how big you need it for you. And that's caching. That's all DynamoDB. It's a nice, easy system to use. End-user authentication. Because we're using the API gateway from Amazon, you can add a custom authorizer in, which basically says whenever a request comes in, to authenticate it, call this other Lambda function, this other bit of code you've written. The API gateway natively supports API keys within it, so I can generate a static key and pass it through. But for us, we're quite interested in that hitting the API with different methods of authentication depending on who it is. So if it's a student coming from the student portal, then that'll come with should come with a JWT, and we decode that, get their data, and so you can only call endpoints that are restricted to your username. You can't call and my colleague Andy can't call my endpoint when he's on Portal, but I can call mine. And that Lambda function basically lets us customize how that authentication is done, depending on what strategies we're using. So it makes it easy for those internal stakeholders. They get that data aggregated from multiple calls to one, and don't have to worry that it's they don't have to go and read the Ex Libris documentation. And for us, it's quite nice that they don't get bogged down and try to understand library terminology. We can return it in business language that they would understand. If you try and explain to an IT developer who develops corporate systems what MMS is and why that's important, and he needs to know what that field is, it's quite difficult. Service development, so we can, because of that authentication, we can easily build services. And then that linking to that internal stakeholders, that single interface to them. But that's also we want to extend to all library systems. So whether it's something we've built in-house, a commercial product we use, if we're having to simplify that data, if it doesn't have a nicer end-user integration that's suitable for us, if we can put it all through one place and we can say, if it comes from the library, if you go here, it'll be documented. We can provide you authentication and say, oh, we've already got some API keys for your server. What services do you need access to do your job or to build what you're building? And just turn them and enable them on for them. So that looks a bit like this. So we have our different devices over here. So we have our mobile app, Amazon Alexa, and Portal. They'll talk through that API gateway. And then each endpoint has a different Lambda function. If you know the Alma APIs, you'll know that that structure is basically the Lambda for endpoint equivalent to the Alma APIs, which is good because we're trying to get that parity of return the data but in a user simple format. And basically how it works is they'll try querying the cache for data. So they'll ask the cache, do you have the loans and requests for Stephen? And he'll go and look and it'll go, yes, it'll return it straight back to the user, it'll be really quick. If it doesn't have it, it'll then be making an API call out to Alma. So at that point, it acts as our proxy caching functionality. It queries through to Alma and lets us get around that. So that's sort of what we've built as that was built on top of the cache as a service we could do to replace something we already had. But what we're really interested in is intelligent user services, and that looks bad. So that's Facebook Messenger, Alexa, and Slack. So that's Facebook and Slack are basically your chat typing interfaces. Alexa is your voice interface, but also something else. So is there something else we should be building that we want to build, or we might want to build in the future? Are we in the stage where we can easily go ahead and build that in the future? So one of the things we built on one of our 20% Hack Fridays was an Alexa skill for Amazon Alexa. So if Alexa's behaving, we'll hopefully be able to see if it works. So Echo, ask the library how many loans are on my account.
You currently don't have any pending requests.
So this is quite interesting, that's language. So we have requests and loans, and with my voice, it really struggles to understand the difference. So I've got Echo, ask the library how many loans are on my account.
Sorry, I don't know that.
Echo, ask the library how many loans are on my account.
You currently don't have any pending requests.
Let's see what the word is. So the good thing with if you're developing for Amazon Alexa is the app actually tells you what it thinks it heard. So I'm going to see what it's decided I've been saying. And if I can just... So if anyone saw my tweet, I said it was very brave of people to do live demos, and now I haven't made a sacrifice to the demo gods. So let's try again. Echo, ask the library how many items are on my account.
You currently don't have any pending requests.
I'll give it one more go. Echo, ask the library how many loans do I have.
You currently have 5 loans on your account. One of these is currently
Wait a minute.
overdue. This is Teach Yourself Microsoft Word 97 in 10 minutes by Peter Aiken. Please return this so you don't incur any fines.
I'll do it again and we'll see how, so you can hear what it's actually saying. So echo, ask the library how many loans are on my account.
You currently don't have any pending requests.
Echo, ask the library how many loans are on my account.
You currently don't have any pending requests.
I'm going to give it one more go and then I'm going to go on to the next slide. Echo, ask the library how many loans do I have.
You currently have 5 loans on your account. One of these is currently overdue. This is Sam's Teach Yourself Microsoft Word 97 in 10 minutes by Peter Aiken. Please return this so you don't incur any fines.
Yeah, I did have to troll our library to try and find, I wanted some actual items on our production thing that worked, so I went down the computer science shelf and went, what do we have that's stupidly outdated and no one will want? And that was what I came up with. So, but as you can see from that demo, voice is very difficult to work with. How people say words in different languages or with different accents is very difficult. And how you do that with Alexa is you give it a load of ways of saying things, and it builds a machine learning voice model behind that it works against. If you have phrases like, if you go, how many requests are on my account and how many loans are on my account, as you've seen from that demo, it really struggles to distinguish between them. And that's something we're trying to figure out with Amazon is how can we deal with that and how we're best developing against that. So I think that's something that we want to look at. To give you an idea of how long that took me to build, it took me about an hour in an afternoon to build that. It's really quick. I did use one of the Amazon demos skills on GitHub to copy and paste some code and tweak it, but because we have that API and we have that cache, it was really quick to build. It's not got the full authentication on it yet, and if people are interested, I'll open source the code for the skill as well, once I've cleaned it up a bit. But on that, all the code for this is open source on GitHub. It's across a lot of different repositories, and everyone can go and use it. These slides are online, and I'll try and put a summary linked with all the different links on for you. Free to, it's all MIT licensed, so just go ahead, use it, submit issues, comments. And one of the interesting ones is what was called Node.Alma API wrapper, which is a confusing thing. And basically, we went ahead and basically went, we're developing a lot of systems, and a lot of time we're doing the same boilerplate coding, and we're basically making SDKs, so software development kits to make it easy for developers to build. So we quite like working with students and student developers, but instead of getting them to write the same boilerplate of which library do I use to query an API, how do I add the authentication key, build that URL up, we went ahead and well, everyone's wanting to do that. When we were trying to do it, I Googled and went on GitHub and went, Alma SDK or Alma X Libris in GitHub, and there's not actually anything there that gives you a nice, easy-to-use wrapper. So we decided, well, we'll just create an organization on GitHub so they're not on the libraries, so everyone can contribute. There's currently only one for Alma for Node.js. It has a limited set of endpoints that the ones we're only using for this project, but it should be really easy using that as a base to go ahead and query it. And we have an internal one that we use for Ruby for Alma, but that basically just passes the request through and passes you the raw data back. It doesn't do the nice things we've done with the Node.js one, which is to create classes. So you have a user class, and you can go user.primary ID, and it will give you back their primary ID, which for getting new people into developing on the APIs is really nice, because it reads a lot more English and domain to them than I need this attribute out of the JSON response. So if you want to get involved, on GitHub, but I would also like to know if people think X Libris should be supporting us and developing these themselves. So thank you, and I'll accept any questions.
Questions?
Hi. You mentioned that user webhook events aren't triggered when the user is modified through the API. if there's an Ex Libris representative, a technical representative, could they tell us why that is?
There is one.
Did Josh already leave?
Has Ex Libris left the building?
Ooh.
I'm from Ex Libris. I'm not sure I can answer the question. Could you please repeat the question?
So when we use webhooks, events are triggered when something happens, and it says in the documentation for the users specifically that if you modify a user using the APIs, then a webhook event isn't triggered. So we can't use which means that the user can only be modified through the interface on Alma. Is there a reason for that? Because the other resources do trigger webhooks when modified through the API.
Not familiar with it.
It's okay, no problem.
One there.
Who's
I'm not an Ex Libris person, but that is a bit silly, but you would need to be able to choose whether it does that. Otherwise, you end up with quite horrible feedback loops if you are both using the API to make changes and listen to the changes. So you should be able to turn that on and off, basically, is what I think. But there are reasons to not have that.
It was what we came up with. The only reason we could logically think was they were trying to stop feedback loops. So people getting a webhook come in and then trying to update something in the API was the only logical thing we could come up with. But if you look in the webhook interface, when you're enabling the integration, you can choose the webhook events you get. So if you know you're building a system that wants to listen to webhooks that aren't user ones and wants to query back the API, just turn it off and create another integration. So we have about 5 different webhook ones that we're trying to consolidate, but also have staging production versions. So
yeah, so we have a system where if it did trigger them, we would have horrible feedback loops. So if anyone from Ex Libris is listening, don't just turn it on. Make it configurable. Yeah.
other questions? Okay. Thank you, Stephen. It was a very excellent presentation.